Okay, in this next section we're going to talk about how to solve rational equations. First of all, some definitions. A rational equation is an equation in which each term contains a rational expression. Rational here and everywhere. Rational is a fancy word for a fraction. In this first example here, linear equation with constants in the denominator. If you look in the denominator, there's just numbers, there's just constants. But this is in fact an example of a rational equation. Second one over here. If you look in the denominator on this example, you have variables. Usually when we talk about solving rational equations, we're talking about these. We're talking about solving equations that have variables in the denominator. Okay, some examples. How do you go about doing that? Anytime you have a variable in the denominator, you have to be careful. You're going to run into what are called restricted values. Restricted values are where the denominator equals 0. You do not want the denominator equal to 0. So restricted values are values of the variable that make the denominator equal to 0. Those are bad. You cannot have that. Okay? So we have to talk about restricted values before we even try to solve the equation. Okay, in this example here, what values of x would make the denominator equal to 0? Well, you take the denominator and you set it equal to 0. X equals 0, we've got to throw that value out. That's a restricted value. This denominator, when does 3x equal 0? Divide both sides by 3 and you get x equals 0 again. So we don't need to include any of that. We've already got x equals 0 as a restricted value. Okay, let's go solve this example. In a previous section we talked about clearing fractions by multiplying every term by the LCD. The LCD in this example here, the first one needs an x, the second one needs a 3 times an x, so the LCD is going to be 3x. I'm going to multiply every term by 3x. When I do that, the x's are gone. I'm left with 3 times 15, which is 45, equals, the 3's and the x's cancel. I'm left with 21, plus 3x times 2 is 6x. To solve for x, first thing I need to do is subtract 21 from both sides. 45 minus 21 is 24. Is equal to 6x. Now I need to divide both sides by 6. And my answer will be 4 equals x. Is this a restricted value? No. So that's my answer to the this problem. Number 2. What are my restricted values? When will that denominator equal to 0? When is x plus 5 equal to 0? Well, that's when x equals negative 5. X equals negative 5 is a restricted value. What about this denominator? Same thing. What about that denominator? Do we have to worry about it? And the answer is no. 4 will never equal 0, so our only restricted value in this problem is x equals negative 5. What is the LCD? This one needs the factor of x plus 5. This one needs the factor of x plus 5, it's already there. And this one needs the factor of 4. So our LCD is going to be 4 times x plus 5. 4 x plus 5, 4 x plus 5, and 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 4 x plus x plus 5. The first term, x plus 5, is going to cancel. You're left with 4 times x equals. The second one, the x plus 5's cancel. You're left with 4 times negative 5, which is negative 20, plus the last term, the 4's cancel, and I'm going to go ahead and distribute that 5. 5 times x is 5x. 5 times 5 is plus 25. On the right hand side I have some like terms. Negative 20 plus 25 gives me 5 plus 5x is equal to 4x. To get the x's on one side, I'm going to subtract the 5x from both sides. 4x minus 5x is negative x equals 5. Divide both sides by negative 1, and x equals negative 5. Now, is that a restricted value? Yes, it is. So, this is not a solution. The answer to this problem is that there is no solution.